Hybrid Cloud Show, episode 30. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So, Sean, you were talking to us off-air about your containers, orchestrating a bunch of things about bootable containers, and I thought we should hold the mic on that and bring it onto the show. So do you want to give us a bit of a rundown on where you're at with your containers and what your questions are?
Yeah. So one of the things that I'm working on is this bootable containers initiative, like you said. And one of the things that I would get a lot of value out of is having my Kubernetes hosts be immutable and defined as a bootable container. That way it just starts up and it just spins up the whole cluster and I'm ready to go. And there's something that's like this already out there called Talos Linux. There's actually a couple of them, but that's like the famous one that a lot of people know about. And Talos, how I have known it to work in my limited experience with it, is you define what your cluster is going to look like beforehand. You generate a config based on that design, and then you boot up your VMs, and then you one by one basically just use this Talos control apply config command, and you point it at each node, and then it, SSHs in, applies the config, and then when you're done, you have a Kubernetes cluster. And I was thinking, okay, that's one way to go about it. I was thinking, could I do this as like a day zero thing? Meaning, what a day zero thing means is as soon as I install the operating system, or as I install whatever I'm going to do, it's already configured, it's out of the box, it's an appliance, it's ready to go. Another way of doing it is as a day one operation, which would be just after I've installed it. Maybe I could do like as a cloud init or a Kickstarter, some other kind of mechanism. So that way it can configure it as it gets installed or just after install. I think that might be an appropriate solution as well. The other thing I could do is a day two operation, which is using some sort of configuration management tool like Ansible to go ahead and configure the cluster as it needs to be done. And what I wanted to ask was, what are your guys' opinions on how Kubernetes clusters should be set up? Is this a good way of going about it? Or do you think there's value in the other tools that are already out there, like the Gateway API and Terraform, to do this for us?
I've always liked the ability to do it as what you would describe as a day one operation, where I'm running some kind of cloud init or some kind of kickstart script off of a known base image, which then goes and deploys whatever it needs to run the relevant version of Kubernetes, which I generally would flag with a variable, and then pull whatever secret it needs and go and join the cluster. I've not seen it done many other ways other than using a managed solution from a cloud provider. So I'd also be interested to see what everyone else thinks. But I suppose the real question is, why are you considering an option other than go and boot from a baked golden image somewhere and run this as kind of a quote unquote day one operation? What is the problem you're trying to solve?
It's not so much a problem. It's more of an improvement. I know that, especially within companies, an immutable operating system that cannot be hacked or cannot be mutated to act as an underlying infrastructure, such as like a hypervisor or Kubernetes node, is a big benefit. And I think that that is something that I want to explore in preparation for a talk I'm going to give on bootable containers for this kind of purpose.
It's interesting because those two things aren't actually linked, are they? There's no reason you couldn't have an immutable operating system on a VM that just runs the containers on top. So, I mean, I know you could in theory do that with something like Ubuntu core with the snapped Kubernetes on top, something like that. You know what I mean? And then you've got your immutable operating system underneath without changing your kind of architecture or the way you're thinking about it.
Yeah, this is kind of a new ground of technology or a new area of technology, and I don't think there's a right way to do it yet. So I just wanted to see what you guys thought would be the best approach to take. I personally also am leaning towards like a day one cloud init kind of thing. I think that would be probably the easiest way to go. That would be most applicable to everyone else. However, I can definitely see some people just wanting to spin up an ISO, right, and just have it go right off the bat. And I think that would just be a little too much overhead for me right now.
So can you tell me a little bit more about Talos to the extent you know about it? What's the sort of approach there? I'm trying to understand how architecturally it's different to that day one approach.
It's kind of between like a day one and day two, because the image itself, the ISO that you install in the VM is tiny. It's like 100 megabytes, and like it has only the things it needs. And even things like the QEMU guest agent, that doesn't come pre-installed. So you have to add that on. But then once you've got that VM up and running, or whatever your host is, then you go in with this Talos control utility and you actually apply the config. And I feel like that's more of like a day two operation.
Yeah, so that feels more like I'm installing a base operating system that has everything I need to join my Kubernetes cluster, plus the Talos runtime with Talos CTL and the other bits and pieces. I install that, I add in the drivers and things that I might need, so the QEMU agent or whatever else, and then I go and manually run Talos CTL config or Talos CTL join cluster or whatever it might be. That feels quite manual and something that I would probably want to automate away.
You got it. So that's what I'm trying to find, where that happy balance is, because I do think you need to have some sort of layer where you actually architect out, right? This is my control plane. These are my data planes. And I don't know whether that should live in Git as a bash script and a config. Don't know yet.
So what about the golden image approach that Gary was talking about? Because that's more similar to what the managed Kubernetes often will do in the clouds, right? They'll bake a new image of, Ubuntu with Kubernetes, and that there is what you then cordon and drain and move on to instead of upgrading those in place. Is that something that people have done in a sort of home environment as well, or in better yet, an on-prem environment?
The golden image works for the most part, but you have to configure still, like, where is my control plane? Where's my master nodes? Point to that, or the load balancer, and that has to come from some sort of config. So that's still more of like a day two operation.
Yeah, so in my example, I'm pulling that configuration as part of that initial user data and then passing those as variables to whatever script it is that I'm then subsequently running in order to join the cluster.
Yeah, so that fits into your day, I think you said day one for that, where it's something that is launching and then using Cloud Init or variables or whatever to do some initial setup of that node to join it into the cluster and be ready to run workloads on top.
Yeah, in my case, this was facilitated by things like Cluster Autoscaler back in the day, where it was using a plugin to look at autoscaling groups in AWS and spin up new nodes when a certain metric was reached. And therefore, I wanted to completely automate the new node gets created by the autoscaling AWS stuff, and then the cluster autoscaler then kicks in and makes sure that that node becomes part of my cluster and is ready to execute workloads. The problem with that is that as part of that user data script, what I'm doing is pulling down the latest set of RPM or DNF updates, for example. So as time goes on and my golden image gets older, the spin up time for scaling my cluster goes from taking 2 minutes to 10 minutes, and then I go back and I bake a new image. But that also becomes a problem when, for example, I've got a 30 gig Docker container image that's a big Python monolith, and it's got to go and pull that from a container registry somewhere. So Sean's approach, I guess, would hopefully reduce that time a little bit in terms of getting the initial thing bootstrapped up and running, so that actually my main concern is then optimization of the size of my 30 gig container image with my Django application in.
That's the intention.
Yeah, that's definitely a good sales point, actually. Like, I've felt so much pain with like variables between environments where I'm running a user data script that sets up a bunch of stuff and it's inconsistent between environments. The more you can bake into the thing beforehand and get confidence in that, and then release with just the application we'll say on top of it as the thing that changes is really valuable.
It also saves me a bunch of expensive CI operations, right? Where I've got something running every day baking me a new golden image, and then I've got to store that somewhere. I've got to do that once per region in my cloud provider or once per account or whatever it might be. And those are really costly applications in terms of compute time.
What if you didn't? What if you did one CI job once and it scaled and moved out to everything? Because that's kind of what I'm trying to do with the bootable containers.
Yeah, well, that's the dream, right? It's not having to worry about that base image baking and building, because I might have to do that once in AWS. or I might have to do that 10 times in AWS. I've got to do that in Azure. I've got to do that on-prem to build my KVM images that I'm going to then boot from. That is not something that is particularly scalable when you go beyond one or two environments in one or two regions, or certainly becomes much more costly to do.
Exactly right. And that's what I'm trying to leverage bootable containers for, using stuff like PyInfra to actually like spin up a VM of my container, test it with all the things I might need, check network connections, check applications are running, whatever my image calls for, and then know it's good to go, right? Pushed out to my image registry, and then every single VM or node or host or whatever it is on whatever platform immediately picks up the update. That's the goal.
Yeah, that's quite nice as well, because like all the path to production is like almost adding labels of confidence to say, okay, I've tested this in dev. All right, now it's in staging or UAT or whatever. I'm getting more and more labels to build more confidence in the exact same thing through the pipeline all the way to production, which is really nice.
How in practice, though, does that differ from just pulling the latest image of, say, Ubuntu off the cloud and then doing your additions on top of that? I'm just thinking that somewhere this image has to be built, and you're saying you don't want to build that in the CI. So if you're not building it, you're going to have to either pull that from somewhere where someone else has done that, or you're going to have to do it yourself. I'm just trying to understand where is that happening?
Well, building a container image is way less costly in terms of compute and CI time than building a golden OS image, right? If you think about if you were to have to deploy an entire Ubuntu QCOW2 image every time you wanted to deploy your application, and you were baking an Ubuntu plus Nginx plus PHP plus MySQL image and publishing that as a QCOW2, that would be crazy, right? And then every box pulls down that QCOW2 to run your application. It just wouldn't do that. So if you do that as a container image, that's a much quicker build and a much quicker and smaller image to run in your CI than building an entire VM.
This episode is sponsored by Insta360. Insta360's X5 is the new flagship 360-degree camera with 8K 360-degree video and enhanced low-light performance for all-angle shooting. Improved audio, 185-minute battery life, and user-replaceable lenses make it the most durable 360-degree camera yet. A new mode captures flat and 360-degree video simultaneously with instant MP4 files for sharing, plus 360-degree footage to reframe later. X5 is perfect for action, content creation, and everyday life. Built from tougher glass, X5's lenses have superior drop resistance capability and are now easily replaceable by the user thanks to a handy replacement lens kit. With its IP68 waterproofing to 15 meters, you can go even deeper without a dive housing. Add the invisible dive case for seamless 360-degree stitching to 60 meters. X5 has a built-in wind guard and improved audio algorithm. A multi-layer steel mesh wind guard silences wind noise, while the boosted algorithm offers sharp, immersive sound. To get a free 114cm invisible selfie stick worth $24.99 with your Insta360 X5 standard package purchase, go to store.insta360.com and use the promo code HybridCloud. Available for the first 30 standard package purchases only. For more information, be sure to check out the links in our show notes. So is the magic of the bootable containers then just the bits that you can't run as a normal container?
Kinda. The magic is that the container image itself comes with the kernel and comes with, the network manager and whatever bare minimum things you need. It's just the base operating system. And then you can layer in whatever applications you need. And you can layer them as RPMs. You can layer them as just quadlets or Docker containers that run, however you normally would orchestrate your containers on any other host. And that's kind of the idea. It just comes out of the box ready to go. And then you have one container image that can run anywhere. And then what you do is you take that container image, turn it into a QCal, turn it into an AMI, turn it into ISO, deploy it on whatever machine, and you're good to go. And then from now on, whenever you push a new image with the corresponding tag, then every host will pick that up and update.
So you don't end up in this cycle of replacement worker nodes in your Kubernetes cluster in the way that you historically would with something like the Bacon AMI approach, where something like those cycle out over time as your cluster scales up and down and you get rid of the oldest worker node, you move the pods over to a new one. Everything just gets that latest bootable container as and when it's published as the production tag.
Yep, that's the intention. You still have to reboot. So let me clarify that. The update is atomic, so you still do have to reboot for that update to take effect, but you can orchestrate that and schedule that on your convenience.
Yeah, and rebooting a node is way less disruptive than spinning up a new node, joining it to the cluster, moving workloads across, shutting down the old one, because that is a pain.
I literally just have like a systemd add-on that just says, before you shut down, drain all your containers, and then shut down, and then it comes back up and says undrain. And that's just part of the startup and shutdown sequence. It's really easy.
So I'm sorry if you've told us this already, but what do these bootable containers run on top of?
They don't run on top of anything. They run on whatever metal you give them. They are the operating system. There's no container runtime powering these bootable containers.
And they're not on top of a hypervisor, so they run on top of bare metal or whatever.
Whatever you want. It has the kernel built in, it has the network modules and whatever else you've baked into your image. There's no extra Podman or Docker, whatever container runtime needed. It runs on bare metal, runs on hypervisors. You can even run it as a container on any other system. You can just run as a podman command, podman run my image, and then it will bring up your container as an operating system. The key difference there being it'll use your current host's kernel to do stuff instead of spinning up its own.
It's a neat trick.
Yeah.
So this is really bringing those cloud native principles to build and run applications to something that you can take and run as a VM, as opposed to working like an old school sysadmin and baking a golden image that you deploy out to machines.
Yeah, I think the term containers kind of put me off, whereas it sounds like this is more an operating system just built with containers as the principle in a way. Like it's not, it's an operating system built in a different way. And so in that respect, how's it different from something like, is it Silverblue or those ones that George Castro has been working on, where you're taking a more cloudy approach to making an image of your operating system? Yeah,
the set of, you want to call them, I guess, images that George is working on are called Universal Blue, and they are bootable containers. They are probably what I would call like the first real implementation of a bootable container and cloud native set of technologies. And that's what I mostly run all my stuff on and what my things are based off of. But I've also been just trying to work with the base underlying technologies, just like Boot C, Compose FS, to try to learn how those work and make things better across the board.
That's interesting. See, when you were talking about bootable containers, I was thinking of things like Kata containers and stuff that were trying to bridge that gap between containers and VMs, but this is quite different.
A little bit.
So this ultimately ends up being something like Red Hat Atomic, doesn't it? Where you have kind of the Red Hat experience built with those cloud native technologies that you just say, hey, host, I want you to now be Red Hat 9 or Red Hat 10 or Red Hat 11. And the host reboots and suddenly it's a Red Hat 11 host.
Exactly right. The Red Hat Atomic product uses Boot C as the underlying fundamental technology for that. So yeah, same principle.
Yeah, and that makes it really easy to do things like orchestrate OpenShift clusters at scale versus having to bake a new OpenShift worker node every 6 months or whatever cadence it is that you need to do for regulatory reasons.
Exactly right. And this kind of stuff allows your OS to scale just like an application would. For example, whenever you bake a golden image, you usually have to put in stuff like, logging, monitoring, right? Add those endpoints in. If you have some sort of like endpoint protection, like CrowdStrike, you have to bake that in. And now you can do all those things and then just have a base image that now anybody else can extend from the same way you would another Docker container. And that makes it really powerful for future people to go and build on top of stuff that you've done.
Yeah, I really like this approach, right? Because if I'm a company that is, for whatever reason, not using Kubernetes or not using containers massively, I can have Red Hat Atomic base, and then I can have my company Red Hat Atomic base plus Nginx and all of our configs and whatever Nginx add-ons that it is we use. And then a developer can go and just deploy their application on top of that. And that gives us an entire operating system that we can take and deploy on bare metal without us having to worry about baking a specific your application as a developer image to go and deploy on those bare metal boxes.
And if you take the bootable container and run it like that just on bare metal hardware or on a hypervisor, is there anything left that is like a container? There's no container runtime, there's no container scheduler or anything like that. It's just like an operating system, right?
That's right. And by default, like Fedora or whatever comes like Podman built in. So if you want to run a container inside of your bootable container, right, then that's like normal. It's just another operating system at that point.
The Talos OS you mentioned is quite interesting in that it does provide that bootable image, but whereas a golden image, I guess all the state is kind of baked into that image. In Talos, it's like a config file that kind of defines the state and that runs on boot. Is that where you would like layer your like, here's the basis for our let's say our company, like here's our security requirements, we'll say. Okay, and then we're going to layer on top of that something else that might be for your specific team. And then, okay, for this particular application, I'm going to layer that. Would that live in that config essentially?
It could. It really depends on how you configure it. But yes, that's exactly what I'm trying to figure out. And then the original premise of this whole topic was, where does that config file live? Does it live in my Git repo? And then whenever I build my container images in CI/CD, it just reads from that and just spits out however many images, right? I could have an image tag for like control panel 1, control panel 2, worker 1, worker 2. Or do I have that config file live somewhere else outside of that repo? And then that gets applied in a very Talos way to the nodes after they've been booted up. And I'm trying to figure out where's the most convenience there. Because they could do things like, for example, my Nginx server that I have at home that runs on bootable containers. I have both the Nginx config and like my application config, like for my applications that I have, are both inside of that repo and both get copied in and run as a quadlet on that container. So that's really helpful. And still, everything's version controlled. I still get all the benefits of, quadlets and having the underlying OS being separated from my application. Awesome. So I'm trying to figure out where that balance is with Kubernetes.
So I'm a big fan of keeping that control plane and data plane stuff separate, right? So for me, there would be the control plane stuff is what takes that node and gets it to a point where it's ready to join the cluster. And that's the control plane piece. And then anything related to secrets to join the cluster or versions of Kubernetes that it would need or prerequisites, images that it needs to pull, all that kind of stuff in order to be a useful worker node in that cluster, to me is more of a data plane operation. And I guess that's really what you're asking, right? Is where do you draw that line between where control plane is and where data plane is? And I think we've probably seen in the case of many public cloud services that that's actually a really difficult thing to do. And you could argue either way as to whether something is control plane or data plane in a lot of cases.
Gary, it sounds like you already went to my talk. Are you a time traveler?
Now, I've been focusing a lot with customers recently on resiliency and really digging deep into this exact topic of how do you treat control plane versus data plane, and what are the specific resiliency principles you need to apply to control plane versus data plane operations, and how you perhaps treat those differently in terms of transactions or updates or upgrades.
Well, I think this is a good point to cut you both off. I have a feeling you could talk about it as long as I would let you. But let's call it there, and we will see you again in 2 weeks. If you've got any questions or comments or feedback, do send them in to show@hybridcloudshow.com. And a quick thank you to our supporters on Patreon and PayPal. If you want to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon, you can receive an ad-free feed of either just this show or all the Late Night Linux family shows, and sometimes you receive episodes early. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.